thanks, Rushank, and first of all, want to thank Postman for this awesome event setup and everything. And thanks so much for coming. We're starting on time, which is awesome, so we have enough time for Q&A and everything else as well. So that's cool. About me, I think Rushank's covered it, but been working with GenAI products for almost 4.5 years now. So I got in early, built products with GPT-2, mostly in the customer support space, then saw the entire evolution from the private beta for GPT-3 all the way to 3.5, ChatGPT, and then GPT-4. So it's been fantastic learning and growing along with the ecosystem itself. And so I'm part of Portkey. For those of you who don't know Portkey, and this talk is not about Portkey, but just a couple of slides. So we're a control panel for AI apps. If you're building an enterprise POC and you're going to production, there are a bunch of challenges you face, especially on the ops side of things. So think of what DevOps did for the cloud from 2012 to 2015 is what LLM ops or FM ops will do for GenAI, and that's the space Portkey is in. We've done over 500 billion tokens that we've processed. We manage over 14,000 prompt templates and work with some really amazing companies. We've done over 200 production deployments now. So I'm happy to share a lot of the learnings that we've also had over time working with all of these companies. But okay, so let's get to the meat of the talk. And I'm specifically going to talk about the AI gateway pattern. That's something that we've discovered is really the key to enabling enterprise-ready products on GenAI. And this talk, I'll especially go very deep into what is an AI gateway, how do we go deeper in it. But just to take a step back, right? The big question I get asked a lot by companies is, how do you get the confidence to launch an AI feature? And that's been a big problem for almost 4 or 5 years. You'll get to POC, the team loves it, you have these wow things, but then going to production, you're always nervous. How do you go to production, right? Cool. So while I'm doing this talk, feel free to communicate. You can raise your hand, I'll stop. I want to answer questions in between. We'll make it interactive so that it's 40 minutes of you really learning and also me learning about your use cases or any questions you might have. So I don't mind. Feel free to raise your hand, I'll stop and we'll take questions. So I'll tell you my story, right? So before this, I was at this company called Pepper Content. But before 2021, and I've done this at Freshworks as well, how many of you have done traditional machine learning before 2021? Okay, there's a lot of you, right? So you would remember the pain. So you would find and clean data, set up your ML pipelines, deploy it somewhere. Some engineers will come say, okay, this is not possible, let's build it like this. Then you'll test out this model, repeat it a few times, get to 40-50% accuracy, and you'll be like, oh, we've cracked it. 40% automation is like insane, right? This was what was usual. But then in Jan 2021, and this is my experience, we were building a AI for content creation app. I literally wrote 10 prompts, connected it to the OpenAI API, and we went live. We went live in 14 days. And that was insane, right? Our sales team was like, oh, you're faking it, this is not true, etc. And that's how the feeling was in 2021. How has this massive shift happened where I don't need to train anything, there's no pipeline, I make an API call and things are getting done for me. And I think that was insane. But then very quickly, I think in a week after that, we ran into problems. How many of you have seen the screen where you're getting rate limited and you're starting to get happy, people are using your tool and you're like, bam, rate limits, not possible, you can't scale anymore. So what do you do about it, right? Engineers, we built load balancing, snaked ourselves into 2 OpenAI accounts, set up load balancing on them, and we've done this, right? And then this one person comes up and leaves a 1-star review saying the AI doesn't work. And we are again lost because we were very happy that we're not doing anything. But the downside of that is everything's a black box. How do you even know what's not working? Who is this user? What did they even do? So we tried Datadog, built our own logging systems and whatnot. But then still every other week, there'll be newer models that were launching. And I think the pace wasn't that much back then. Now if you see every other week there's a better model. I mean, every time I do this talk, there's a new latest model. Right now it's I think Sonnet 3.5, that's all the rage. And these are newer models. How do you deploy these to production every single time? Every time go back to the software lifecycle, build out this new model, ship it to production, test if it is working for your use case or not. Yeah, it's just messy. And then obviously hallucinations, I've not mentioned it because I think everybody knows about it, but let's talk about the problem with hallucinations. You know, you have cases like this, where some smart guy will come and say, okay, I'm going to buy a Chevy Tahoe for $1 and I'll trick your chatbot into doing it. So how do you prevent cases like this? Right? And while this might have been a joke, but I think Air Canada, if you know some of these situations, they got into legal trouble for it. And I don't think the courts or the legal system have caught up with what all is possible with AI, what does hallucination even mean. So you still have to build some of these safeguards, guardrails in your product. And you know, so we basically grappled with almost all of these problems over 2 years. And while that was very frustrating for Ayush and me back then, now we use that opportunity to sort of also solve a lot of these capabilities, right? So I think one big insight we had was, these are actually ops challenges. These aren't very AI challenges. The AI is doing what it's supposed to do, but we've not built the right ops around it, which is where I said, this was the same problem that happened with cloud as well. Cloud adoption was really low till DevOps came in and said, let us provide a very strong foundation for you to take your products to production on the cloud. And I think that's the same here as well. So we're proposing the AI gateway pattern, which is, you will most probably start with this. You have your AI application, you have your frameworks with LangChain, Llama Index, Crew, whatever you're using. And that application is calling an AI model, right? And you can have multiple models, etc. So how do we go from this setup, which is prone with all of these problems that we mentioned, to something like this? This is the AI gateway pattern that we are proposing, which is your AI application now can connect to the entire plethora of AI models through the AI gateway. And the AI gateway is obviously a wordplay on API gateway, because this is something we've seen with microservices. But the AI gateway difference is, it does a bunch of stuff specifically for GenAI products, right? And let's go through them one by one on what have been the most popular use cases we've seen really. Yeah. So obviously the first is routing, where the AI gateway can now provide a unified API across all of these models. So I'm using OpenAI, Sonnet 3.5 is launching, but then Anthropic has a lot of these different things. You can send in a default message. You need to have system user assistant only. You can't have 2 user messages. So there are a bunch of things you have to take into account when you're shifting between providers or shifting between models. And how we do that is, can we create a unified API signature? And what our AI gateway does is we are following the OpenAI signature. So if you're using the OpenAI SDK, you can just route requests through the gateway and switch models as effectively. Then obviously we went one step further, and the gateway can also then do some interesting stuff like load balancing. So I now have multiple models or multiple providers. Can I split my load across providers using some weight-based or some advanced routing capabilities? We built fallbacks. So if OpenAI is down, fall back to another. If the context length does not solve, my context length is longer, switch to a longer context length model. So those fallbacks, retries, timeouts, all of this become really easy to build here. And I know a lot of them are already being built on the application side, but this architecture is actually proposing that you move it to the gateway. Saves you system compute, saves you time, and also you don't need to manage all of these systems yourself. So that's routing. Yes.
So you were told about routing to different models, right?
Yeah.
How to make it seamless performance across them, because all the models are not same, right?
Yes.
So how to make sure you get some some metrics and try to make it understand?
Yeah, absolutely. So I would say observability is really important there. So you can actually measure your performance, cost, and accuracy across models using observability on the gateway. But I can tell you the simple tip, which is you should always do load balancing between similar models or similar sized models. Like I would never recommend a load balancing between a Llama 8B versus a GPT-4o. They are not similar models, so you'll get wildly different outputs. But maybe you can load balance between a GPT-4o and a Sonnet 3.5. They'll be fairly easy. But it's still about a lot of benchmarking that you'll have to do.
You need to say, you are saying while testing you have to do it, or when dynamically when you are doing the routing, you will manage it, I'm asking.
So definitely you have to do it during testing first. Once you're confident, but production use cases are very different from testing. So it's always good to also test it in production. And you can say, okay, 5% of my traffic moved to this model, let's see how it works. Yeah.
So does that not suppose the use case or the case for moving that logic inside the app itself and not on the gateway?
Yeah. I mean, these are biases, right? It's like Vim versus Emacs. I want to do.
Enough to
Yes.
route it to Gemini versus Anthropic without
Yeah.
asking me.
Oh yeah. So okay, smart model routing is something that so I'll tell you a story, right?
I meant over smart, sorry.
Over smart, right?
Is
Yeah.
Is over smart enough to say, okay,
Yeah.
I'm getting 404, let me fall back to Gemini. And
Yeah.
I am oblivious to what's happening in the gateway.
Yeah.
So that's precisely the case why that fallback logic is always in the application layer and not in the gateway. Gateway should be a dumb pipeline for
Yeah.
not if it also starts making decisions on my behalf,
Mm-hmm.
then there are two animals to take care of.
Yeah. I think if it is smart to that extent that it's doing a lot of things automatically, then no. But if it is a configuration-based fallback system, where you've said that, okay, if it gives you a 404, switch to this model. And that configuration is something that you would define on the gateway. So then it's better to have it on the gateway than have it in your application, because tomorrow when you want to change a model or add another fallback, do you want to do that on your application side again? And this is where I think the same concept applies with API gateways as well, where you actually are like with microservices architecture, you would build fallbacks on the gateway rather than building all of this within your
API
application.
gateway has a separate concept where the fallback itself is a mirror image, probably in a different availability zone.
Yes.
The same code running.
Correct.
We're talking about Anthropic
Yes.
versus
Yeah.
Gemini or.
So there is some amount of intelligence you will have to also do to set it up here. You can screw it up big time. But yes, I think those are checks and balances that the developer owns in the end.
So basically,
Yes.
what you're saying is, once again, just to continue, so suppose you have 5 models
Yes.
for simplicity. So I will set the rules. Model A, B, C, D, and it can be anything, GPT-4 to GPT-2.
You will decide, but it's a deterministic configuration that you're setting up on the gateway, on how these things will happen. Yes.
So you have basically married yourself to the OpenAI interface, right?
Yes.
How future-proof it is, because right now OpenAI is leading, so it is basically the trendsetter.
Yes.
Either it is tools or it is basically sending attachments.
Mm-hmm.
Anthropic released this artifacts, and if they release their API around artifacts,
Yeah.
so basically how future-proof it is going to be, because tying yourself with the OpenAI interface, you are just saying this is the capability we are going to.
Yeah, I understand. So, great question. I'm guessing if I were to summarize, is the OpenAI API signature future-proof, right? So, I think I would say, one, it's a starting place, and it's a really good signature because of which I think everybody else has also adopted mostly the OpenAI signature itself. Like Anthropic with its messages API moved to the OpenAI signature. Mistral moved to the OpenAI signature. So I think it's similar signatures, but people are adding their own flavors and parameters to it. So while I would say that we are based on the signature, we're not completely tied to the signature. We will also keep expanding as more things come into place. But I would still say, like right now, it's 90% OpenAI signature. Yeah. Yes.
Yeah, so in an API gateway, the request remains the same. The
Yeah.
endpoint is what it changes. You're trying to give a similar view over here, but in reality, wouldn't the prompt actually change? Like if I had actually tuned my prompt for Gemini, what GPT-4o is,
Yes.
it's great to expect it, but if I want to build a production application, I'm going to tune it for GPT-4o separately.
Yeah.
So I understand the fallback logic, but shouldn't the prompt also fall back when I'm falling back from one model to the other model?
Yes. And that's possible. So you can have different prompts, which is where prompt management comes in. So that's,
Okay, so even the gateway is doing now prompt management.
you can because Portkey does prompt management, you can store your prompts here.
That is an application.
Folks, just to
It is not.
Let's come
Yes.
back to the Q&A.
Yeah.
Right, so we'll take some questions
Yeah.
while the talk is on, and then we can take some more.
Yeah, maybe a discussion we can do later. I'm sure you have a lot of questions because of your setup, but happy to take more questions there, yes.
Let's
We-
continue, then we can come back.
Yeah, we'll just come back to this, right? Okay. So yeah, so we talked about routing. So how do you do load balancing, fallbacks? Then you can actually capture all of these request response parameters on the observability layer in the AI gateway itself. So we are today capturing 40 LLM metrics on cost, accuracy, and performance. So all of these are according to us, the 3 axes on which you will start to measure your LLM models or your LLM applications. And that's what's possible with the observability piece here. It's connected to a dashboard, so all of your data is now pushing it into a dashboard itself. The third is guardrails, which is how do you prevent or just run through a checklist on your request and response. We talked about prompt management a little bit. I'll tell you more in the following slides. And then there's overall a security layer here. So how do I make sure my keys are not getting compromised to the developers? How am I building disposable keys, imposing budget limits, rate limits, and all of that? So that's the duty of the AI gateway. And this enables you to take out a lot of the ops stuff out of your application into the gateway itself. Right. So our gateway, we've open sourced, Portkey's AI gateway is open source. It's available on GitHub, so you can take a look at it. We support almost 30 providers now. And we've partnered with Nginx to be, okay, what is the default AI gateway that comes along with API gateways as well. So if anybody just wants to go check out this library, I'll share these slides anyway later, but that's available.
What's the license that you're using?
We are an MIT license.
MIT license.
Yes. So we launched, I think we open sourced our AI gateway in January. And again, with the same questions quite a bit, right? Oh, why don't I just build this in my application? I need it here and I don't want it outside. And I think these are 2 schools of thought. We've seen over time, as more teams adopt GenAI features within the company, it's better to route them through a singular gateway. And that's sort of how it works.
So there are any competitors, like any other open source is available AI gateway?
So I think open source, there are many. Even closed source, there is Databricks launched their AI gateway, Cloudflare launched their AI gateway. Kong is launching their AI gateway. So I think it's a concept that's becoming more and more popular over the last 4-5 months at least. Yeah.
Folks, please keep the questions.
Yeah.
We'll have a lot of time for the questions.
I think we can take 1 or 2 questions and then I can keep continuing. Yes.
No, I'm asking what is the differentiator?
Okay. Yeah. I think that's a longer conversation. We'll come to that. Yeah. Because I think I would hate to bias it to say, okay, this is what Portkey does. And I'm sure we are much better than everybody else, but it's a biased thing. Yes.
So you said there are 3 axes. So you said there are 3 axes that make the ML model, right?
Correct.
So when it comes to accuracy, specifically for the prompts and the LLM, right?
Yeah.
How do you measure that? Like, what is the criteria is the accuracy one?
Yes. So I think accuracy is, different companies measure it differently. But for us, I think the best result comes from a human plus automated feedback score. So humans are basically, whenever you get a response, you have human feedback coming in. Could be something more complex, could be as simple as a thumbs up, thumbs down. So that's human feedback coming in. The second piece is you're running a bunch of guardrails at the gateway itself, which is feeding all of this data back to you. And maybe I'll just come to how you can collect that feedback and make it useful for you, right? But essentially, if I were to open up Portkey AI Gateway and how the entire concept of AI Gateway is, that is essentially this large architecture diagram. And what I'm going to do is I'm going to just go through this one by one. so that you actually understand what this pattern entails, more or less. So like step one is how do you do inference? So what happens is you have your business logic, where you have your vault, which has API keys. It has a context manager, especially helpful if you're doing RAG. And you have your prompt management and versioning systems. These all feed into your GenAI service, which then makes a request to the AI gateway. This AI gateway, the first part of this is a transformer, which is a unified request response transformer. So your request is actually coming into one signature. The gateway will transform it into the destination signature. We talked about load balancing, fallbacks, caching, automatic retries, timeouts that are applied at the gateway level itself. And then this request is passed on to the inference stack. This inference stack will have its own firewalls, rate limits, redaction of sensitive data, and is then passed on to the LLM, where you have the cloud-hosted models, the self-hosted models, or any fine-tunes that are happening. So that is the forward pass, where all of your data is now, so the inference call has been triggered to the LLM. On the way back, the LLM responds. You will run it through a guardrail system. And these are a combination of deterministic guardrails. So these could be regex, contains, these many characters, these many tokens, etc. Could also be model graded. So I don't want hallucinations. I want this to match my, some semantic similarity, etc. So that combination of evaluations or guardrails run on this output, which then goes back to the gateway, transform it back to a common signature, and is sent back to your GenAI service. So this is the inference flow. But what also can happen in parallel is the gateway is actually sending this data to an observability stack. So you have your observability stack, whatever it's set up. You can process these logs, and there are 3 steps to it, right? You have to tokenize all of the data there, calculate the costs. Every model has a different cost. If you're running your own GPUs, there's a different cost calculation. And then there's some amount of data masking that will happen, so you can store this data securely within your centers. Run through data pipelines, and then set up alerting monitoring. So this is the observability flow, where all of this data is now available for you to view later on as well. The side effect of observability,
Just going back, in the serving the response, you have the guardrails.
Yes.
Generally, it is a streamed response.
Yeah.
So, isn't it too late to basically have the guardrail kicked in?
So, yeah, I think there are a couple of ways you can do this. One is there are streaming guardrail services that are available today. So as you're streaming, you can have some logical points at which you're evaluating the output for certain things, and then you're sending it out. In a lot of cases, you might not want, or you might not even stop the stream. You might validate the output and just log it as feedback. So both of these are possible, but depends on how you want it. With a streaming response, you can have like logical points in between that you're checking, or you can just check it at the very end.
But guardrails are to, avoid sending back response that might
Yes.
be,
Yeah. So I think for some of those use cases, which are especially around toxicity, moderation checks, etc., those are all possible even at like certain junctions in between. So what you would do is you're not doing it at every token level, but you will find out what's a coherent set of tokens that you can then verify and then pass along forward. Yeah.
So how much delay this AI gateway adds? Because you are talking about many functionality, right?
Yes.
Is this introduce some significant delay, or because LLMs are not as fast, right? Like
Yes.
it's still slow.
Yeah.
It takes many seconds.
Yes.
So how much delay?
So if I take out the guardrails aspect, because the guardrails, when you're doing a model graded evaluation, that might take longer. But if I take that out, the gateway is actually supposed to be extremely performant. So it will be like sub-millisecond latencies on the gateway. So it doesn't introduce latencies because everything is just pass-throughs.
What kind of implementation?
So the open source version is you can deploy it yourself. We have a SaaS version as well, which is deployed on the edge. So we use Cloudflare functions, and we've deployed the gateway on the edge.
So you were saying lesser than 1 second.
within the gateway, but if there is a round trip time addition, if you use the SaaS service which is hosted, that we benchmarked at a 95 percentile to be less than 40 ms. 40 milliseconds, less than 40 milliseconds, 95th percentile. Right. Okay. So the other side effect of observability is also training. Now this data that you have is actually extremely useful because you have request responses, it's structured data, and you probably also have some feedback data attached to these logs. So you have those request responses attached to logs. You can use this in your training pipeline as well, which is how do you continuously fine-tune your model using this data that's available. This is something that it's a fairly new concept, which is autonomous fine-tuning. But I would say even if you're not doing the training today, this data is extremely useful. So if you're running any pipelines, always good to have this data available after it's been scrubbed of all PII. So you can use this for training at a later point in time. It becomes extremely helpful. So yeah, that was the overall AI gateway pattern. So we've talked about where prompt management comes in, security, guardrails, routing, and observability. And this, I think this talk is more about the gateway pattern that we've seen now deployed across these 200 odd companies and the learnings that we've had from it. Yeah.